The 8051 microcontroller cannot work without a clock signal. This clock is generated using a crystal oscillator, and its frequency decides how fast and how accurately the 8051 operates. In this video, we will focus mainly on crystal frequency and also explain baud rate, clock edges, frequency generation, and why a clock is required. What is crystal frequency? Crystal frequency is the oscillation speed of the quartz crystal connected to the 8051 microcontroller. The crystal vibrates due to the piezoelectric effect, producing a very stable square wave clock signal. This signal acts as a timing reference for the entire microcontroller. Without crystal frequency, the 8051 cannot execute instructions, count time, communicate serially. How clock frequency is generated. In the 8051, the crystal is connected between XDL1 and XDL2 pins. When power is applied, the internal oscillator circuit activates. The crystal starts oscillating. A continuous clock waveform is generated. This clock is distributed internally to CPU, timers, serial port, control logic, clock frequency, and machine cycle. The classic 8051 architecture uses 1 machine cycle equals 12 clock cycles. If the crystal frequency is 11.0592 MHz, machine cycle time equals 12 divided 11.0592 MHz is almost equal to 1.085 s. Each instruction requires one or more machine cycles, so crystal frequency directly controls execution speed. Clock edges, why they matter. The 8051 operates based on clock edges. A clock edge is the transition of the clock signal. Low-high rising edge. High-low falling edge. At these edges, registers update, instructions advance, data is transferred. So, each clock edge acts like a trigger telling the microcontroller, do the next step now. Why 11.0592 MHz is preferred? 11.0592 MHz is not random. It is chosen because it divides exactly to standard serial baud rates. This gives zero baud rate error, which is critical for UART communication. RS-232. Data accuracy. Using 12 MHz can introduce timing errors in serial communication. Baud rate means bits transmitted per second. In the 8051, baud rate is derived from the crystal frequency. Timers use clock pulses to generate baud rate. If the crystal frequency is inaccurate, baud rate becomes inaccurate. Serial communication fails. That's why crystal selection is critical in embedded systems. Why a clock is absolutely necessary. The clock provides instruction timing, synchronization, accurate delays, reliable communication. Think of the clock as a heartbeat of the microcontroller. No clock equals no life. So, the crystal frequency is not just a number. It controls speed, accuracy, and communication reliability of the 8051 microcontroller. If you understand the crystal, you understand the heart of the 8051.